So last night we did a little online shopping, Parker, to investigate some differences, not only between the cost in different sized items, but the cost between different stores. And so this section down here where you had to find the cost per ounce, you took the cost and divided it by the quantity, right? The amount of ounces that maybe the package contained. Did anyone have to like zoom in on the packaging to see what the ounces were or the fluid ounces were? Sometimes it's not like easy to see right on the picture. You have to like zoom in to the corner of the packaging and it will tell you the ounces. What did you experience?
And from Walmart, it just gives you the ounce and the cents. Yeah.
Okay, so I'm hearing on Walmart, they gave you the flat out cost per ounce on the website. You didn't have to do the calculating at all. All right, Ava, what'd you notice?
I noticed on some of the packaging, like I noticed on the mac and cheese, it didn't tell you what the ounces were. It was on the box.
Okay, let her talk.
I zoom in on the box.
Okay.
It didn't just tell you on the box.
She said it didn't tell the amount of ounces on the listing, but it did tell her when she zoomed into the picture. So sometimes it's not listed on the website, but you have to zoom into the packaging to see the amount of ounces in the package. If you have to. What did you notice was the item that cost the least amount per ounce? Not that cost the least amount, but cost the least amount per ounce. Anyone at home or here?
Minute Maid.
Yes, they have it. I got Minute Maid.
Minute Maid was the least. Okay, Gavin, what'd you get? Same?
Yeah.
Orange juice? Everyone get orange juice was the least expensive per ounce.
Yes.
Okay, what was the most expensive per ounce?
Cool Whip.
Cool Whip, Oreo, sometimes depending on where you shop for those Oreos might have been more expensive. But Cool Whip was
23.
pretty much the most expensive per ounce. So here's, I guess, my final question about this section. Why? Why does orange juice cost less per ounce than Cool Whip? Why? Why do you think that is? Why is Cool Whip more expensive per ounce? What's your thought on that theory?
Orange juice probably is easier to make than the Cool Whip.
So Parker said orange juice could be easier to make than Cool Whip. Good idea. Okay, what else are you thinking, Riley?
Cool Whip might be at a higher demand than orange juice.
She said Cool Whip might be a higher demand product than orange juice. Okay, good theory. Zoe?
Orange juice could be like easier to package.
Orange juice could be an easier manufacturing process. The packaging might be cheaper. Do you think maybe the ingredients needed might be cheaper? Okay, maybe the ingredients for Cool Whip are more expensive and therefore you're going to bear that cost as the consumer and pay more for the actual per ounce price. What else? What do you think, Gavin?
I was thinking maybe because it's the only one on here that had fluid ounces and not ounces.
Oh, so his thought is related to, you know, this specific product is a liquid and maybe liquid costs less overall than these packaged products that are solids. That's a thought. It's good to think of all of these possibilities about, well, why does this product cost more or less? What does that mean for me as the consumer?
Branding.
So I have, yeah, that was where I was going next. These are all national brands. These are all brands you can find across the country in many different stores. The alternative is called the generic or store brand, like the Kroger brand or the Walmart brand. And often, since those companies don't really advertise their products in magazines and on media outlets, they're going to cost less overall. Not necessarily different types of ingredients, maybe slightly, but a container of Kroger orange juice has nearly the same ingredients as a container of Minute Maid orange juice, but it costs significantly less, right? So if you're willing to accept a difference in taste or or a slight difference in the packaging, the way that it looks. It's often the national brands spend a lot of money marketing and making it look as attractive as possible so that you want to buy it. You think it's going to taste better because of the way that it looks. So national brands spend a lot more money, and then who ends up paying for that marketing? You do as the consumer. Your product costs more than the generic brand. All right, let's scoot down a little bit. What did you learn about price per ounce when you investigated different sizes, different quantities of the same product? Did you find for the peanut butter it really mattered that much?
Yes.
Size to size. What was, Santo, is that you?
Yes, that was me who was speaking.
What was the peanut butter that you found was the least amount per ounce? What size was it?
Least amount per ounce was actually the 80 ounces that you get from the Kroger family deal.
Okay, so a big container of it, right? So maybe we're thinking that buying more at one time is going to save you money in the long run if you can use this product over time. If it's going to spoil quickly and you can't use it, or you don't have the space to store it in your house, I mean, I'd like to buy a big can of peanut butter. It will save me money, but I don't have space for it in my tiny little Dearborn house. So I have to find a size that meets my needs and my wants. What did we find about the mayonnaise? Someone here in the classroom, what did we find about the mayonnaise? Isaac, what did you discover about the mayonnaise? Again, he said the largest container gave me the better deal. So we're starting to notice a theme here that typically you're rewarded as a customer for buying a larger quantity up front because they don't have to repackage their product every time you buy a smaller quantity. You're saving them money. So when you save them money on packaging, they're going to kind of reward you and charge you less per ounce. So if you can buy in bulk, it's called, it's often a better deal unless something is what? On sale. Unless something's on sale. And I'm going to tell you this example that just happened to me last week. My family eats goldfish like water. I don't get it. I don't get it. But they sell, you know, those giant cartons of goldfish, and then they sell the little bags of them, right? So the giant carton of goldfish and the little bag are pretty comparable price per ounce normally. But the little bags were on sale last week. They were like $1 a piece compared to the big carton was normally, I think, $5.99. But the price per ounce significantly changed when they went on sale. So instead of buying a big carton of what I needed, I just bought like 4 or 5 little bags that were equal in size because it saved me money. So sometimes the bigger box isn't always the better deal. You have to really investigate the cost divided by what you're getting to find the overall value. Katerina?
Another thing too is that in cereals, sometimes like it's a big box, sometimes it's like chopped off and they don't fill up all the way, like the bag. And that's like what I've noticed.
Katerina thinks she's getting scammed on cereal quantities. It feels like it when you open the bag of chips and you're like, wait a minute, they're halfway gone.
It's like it's like the people who put them in the bag were really hungry until they ate.
No, that's not why. Guys, that air bubble that's in the package is so that the crispy product doesn't get crushed. That's why it's there. So, and it does settle. Like once it's filled with the cereal, it settles a little bit. So it kind of nestles down into the box a little bit more. But potato chips are always the worst when you open it up and it looks like half the bag is gone before you even started. All right. We need you to open to workbook 185, please. We're going to be looking at proportions a little bit more with other real world situations here, okay? Proportions. And I'm actually gonna start on 186. We'll go back to 185 in a little bit. 186, please. All right, I'm gonna try and write on the board. Hopefully we're having a good day with the board today.
Oh, it is actually.
Is it having a good day?
Yeah, it's been pretty good.
All
for
right,
others.
let's see. Is she having a good day today?
It's been pretty good for the other.
How are you?
Please cooperate, Miss Board. All right. I want to read the context and then develop a proportion that helps us solve for the unknown part. So a proportion is nothing more than one ratio being set equal to another ratio. So this is the structure for a proportion. Oh, she's behaving pretty nicely. We have one ratio on the left set equal to one ratio on the right. All right? So everyone set up the proportion, and then we're going to plug in the spots that we know. So let's read the context. A volleyball league has 156 players on 13 different teams. If each team has the same number of players, how many players are on 9 teams? So what we have to find first is one direct relationship. What's one direct relationship that we can read from that context? What's one direct connection? What do you see, Alicia?
156 players on 13 teams.
Okay, if you happen to have a highlighter, highlight this, and if you have a pencil, just underline it. 156 players on 13 teams. That is the relationship we know is true. So that's the relationship we're going to put on the left-hand side of the ratio, okay? So we're going to put 156 players on 13 teams. That's what we're putting on the left. Now we're going to use that relationship and relate it to a similar scenario and find a missing component. So what other bit of information am I given? I'm given the amount of teams, and I want to know how many players are on 9 teams, right? So knowing what we do about ratios, should I put the 9 teams up here on the top or down here on the bottom? Where should I put the 9 teams? What do you think? On the bottom, why? Why on the bottom? Because the one on the left has teams where? On the bottom. So on the right, we have to also put teams. That way they maintain their equivalency, okay? So put 9 teams on the bottom, right-hand side. And then this is our mystery spot, right? This is the part we don't know. That's the part we have to try and find out. Yes.
So you said that, if like the teams, the 13 teams is on the bottom, we put the 9 teams on the bottom.
Yes.
But what if 13 is on the top, right?
Then we would put it on the top. She said, what if when I wrote this, I put the 13 on the top to begin with and the 156 on the bottom? Then your ratio flips basically, but they're still related exactly the same. You're still going to get the same answer as long as you keep that relationship in position where it needs to go. All right, so my next instinct is to say, all right, I have a missing part. What I normally do is ask myself, what factor helped me get from 13 to 9, right? I normally am asking myself that, but I don't know any factor that helps me get 13 to 9, do you? Ooh. I'm going to tell you this secret trick that works. It's called cross multiply. Oh my gosh. But it's not a big deal.
It is a big deal.
What about in science?
Listen to this. This is so awesome that it works this way because you get saved from a whole bunch of calculations. I'm going to tell you that this times this will be equal to this times this. How is that hard? Why is that? Oh, it should be yay. It should be yay. This is the exact way Mrs. Zimmerman does. But okay, so what does that mean? It means 156 times 9. I'm going to write it over here. What will it be equal to? 13 times x, right?
Miss Zimmerman makes us do it in parentheses.
Oh, that's fine. If you want to do it in parentheses.
No,
What it means is 156 times 9 is equal to 13 times x. If you happen to have a calculator with you, I don't mind you using it. What is 156 times 9? What is this equal to?
1,000.
This?
Yeah.
Okay, we still are equal to 13 times x, right? So how do I solve for x? How do I solve that missing piece?
You divide.
I divide both sides by what? 13. So this is algebra coming in. I would say identify the variable, right? What's the balance move? Is to divide both sides by what? 13. That would eliminate the 13.
So 1377 isn't right.
What is it supposed to be?
1,400.
All right, guys, I don't know who told me this. Come on, you're ruining my credentials here. You're ruining my fidel. 1,404?
Yeah.
Okay. What is 1,404 divided by 13?
108.
X is equal to 108. So what does that mean?
108.
It means that right here, how many players are on 9 teams? 108 what? 108 players are on 9 teams.
Is it okay if you abbreviate it like P?
Yes, you can abbreviate it, but it has to be abbreviated in a way that's different from the thing on the bottom. So if they both start with PL, you can't use PL for both of them. Do you see how we've set up a proportion? And then instead of using a common factor today, we're going to use cross multiplication to solve for the missing part. All right, number 2. I'm going to erase this calculation stuff.
Let me start number 2.
Here, let's set up a proportion first. A little.
You can move the size of the eraser.
I know. I just didn't want to do all this extra business. All right, so we set up a proportion, read the information. Let's try and structure something that will make sense. There are 78 calories in 3 ounces of frozen yogurt. Okay, so what's the relationship we know for sure? Isaac, what is it? All right, I'm going to highlight that. There are 78 calories in 3 ounces of frozen yogurt. So that's the relationship I know for sure. So let's put it up on the proportion. 78 calories in 3 ounces. So the question is asking me, how many calories are in 8 ounces? So does 8 ounces belong on the top or on the bottom? It belongs in the bottom because I'm looking to find how many calories, this is the unknown part, with 8 ounces. Let me check on my chat box here. Okay. Let me try and reshare this, guys.
Oh, wait, so we didn't see the
Wow.
art. Wait, so we didn't see the last problem?
Can you see it now? Someone's got to unmute and like talk to me when this is happening because
No, we can't see it.
Cannot see it.
did you see the first problem?
We couldn't see anything.
Why didn't you?
Okay, why didn't anybody speak up? I can only manage so much here, guys. If I don't know that you can't see it, I didn't know that. That's a really big delay for you if you didn't know what I'm talking about at all.
At least you're recording.
Yes, but I doubt the recording is catching the annotating if theirs isn't. Let's see. I'm gonna try it this way now.
Oh, are they not seeing the annotating?
Yes, they're not seeing the annotating. Let's try it this way. I'm gonna set it up using this application instead. Can you see that writing now? Guys gotta speak up from home.
Yes.
We can see it.
Yeah.
Yes? Okay, there we go.
Yay.
So we're setting up a proportion, and a proportion is one ratio is equal to the next. we scanned the information and we saw that this is the part that I know for sure. This is the relationship I know for sure. So I'm going to use that part in this side of the ratio. 78 calories for every 3 ounces. I'm looking to find how many calories relate to 8 ounces. So this is the unknown part. We just talked about how cross-multiplying is a tool you can use when common factor approach just won't work. So what's cross-multiplying help you with? Solving for the unknown spot by using this algorithm that'll get the job done. I know that 78 times 8 will be equal to what? 3 times x. So what is 78 times 8?
624.
624?
Yes.
Do it again. In case it's 624 equal to 3x. So how do I solve for x? It's nothing more than an algebra problem.
You make a bounce.
I identify the variable and I say, hey, how do I unstick a 3 times the x? I do the opposite of what's 3 times x. I'm gonna do, wow, this is really right. You guys said it was writing nicely today. It's not writing nicely.
That's because you're using annotation.
That's because I'm using the Zoom annotation and not Active Inspire. So 624 divided by 3 equals what?
208.
208. So what does that mean in the context of the problem?
208 calories.
208 calories are in an 8-ounce cup of yogurt. Okay? Now, we had a little bit of a delay here today. We're going to come back to this workbook page, but I like the worksheet that I made a little bit better because it helps solidify this topic of cross-multiplying better than your book. Your book's trying to handle too many things all at once. It's trying to handle you reading a story problem and setting up a proportion properly and using a new skill, cross-multiplying to get it done. I'm going to give you a worksheet that just has proportions on it right now, and you guys can pull it up on the screen at home. So close your workbook right now. This will definitely be a little bit easier than what we just did because we don't have to dig through the context of a problem. The proportions are all set up for you. We're just going to practice cross-multiplying to solve, okay? Anyone want to run through the room here and test things out? Yes, we are going to use calculators too. Okay, we are going to use calculators. Let me pull it up on the screen.
Can I get my calculator?
Yes.
Skip me. I did. You did.
I would skip it.
All right, everyone can see my worksheet?
Oh, it already has the proportion set up?
Yes, proportions are all set up for you. Now, please, take a highlighter. Take a highlighter and establish the cross multiplying. 40 times A will be equal to 24 times 20. Everyone take a highlighter and.
Can we just like draw lines?
No, a highlighter. I don't want you to cover up the answers. Just set them down.
Are they both the same worksheet?
Yes.
Okay. Are you not using your thing today?
What thing?
Your tab thing. Where you use the pen?
No. It was too much work to set it up. I was out of time. Okay.
All of them?
Highlight the cross multiplying going on in all of them. And then you see that little empty space that's just below the proportion. We are going to write an equivalent expression. So you tell me, what does letter, instead of numbered 1, 2, 3, 4, they're lettered A, B, C, D, okay? Letter A, what is the equivalency? 40 times A is equal to what? What's 40 times A equal to, everybody? Is equal to 20 times 24. This is what I want you to write on your paper.
Is it okay if you put 24?
I want you to write the equivalency. Does it matter? I heard someone say, if you put 20 times 24 first and 40A second, does that matter? No.
I meant like if you swap 20.
Nope, doesn't matter either.
Okay.
Because multiplication is commutative. As long as the 24 and the 20 are stuck together on one side, and the 40 and the A are stuck together on the other side, we're fine. We're going to get the same answer. Now I want you to take out your calculator if you're using it. You don't really need it. These aren't really super big problems. What's 20 times 24? 480, okay? So we know that this side is equal to 480. So you can write it under there. Mine is a little bit slimmer on space. I'm wondering if you have a little more room. And 480 is equal to 40A. How do I solve for 40A?
You divide.
I'm going to divide both sides by 40, right? I'm going to divide both sides by 40 in order to find the answer for A. What would the answer for A be, everybody? 12. Okay, so I'm going to get rid of all this stuff that's in the way. And I'm going to put 12 here next to the answer. Now, I understand you're able to use a calculator, but I want you to write the cross multiplication statement under each problem. So what would we write under B? What is the equivalency? 33 times 16 will be equal to what?
11 times.
11A. Okay, as long as you can write that, I'm happy.
Can we use a loosely just to do our work on? Yeah.
Sure. 33 times 16, or the back of the paper, John, will be equal to 11 times A. So let's see if we can do that one here together. What would 33 times 16 be? You got it, Sloan? 500 and what? 528. What would 528 divided by 11 be?
48.
What did you get?
48.
48?
Oh, wait, this is what we have to do?
That's it. Yes. So what that means is 33 out of 48 is equal in value to 11 out of 16. Their ratios, their relationship is equal to each other. People at home, I'm sorry that that first problem wasn't on the video. How are we feeling about this? About the cross multiplying?
Good.
Guys have to speak up if something's not right, and I'll do my best to fix it. I'm sorry it wasn't on the screen.
Can we do one more?
Yeah, let's do another one. I want people from home helping me out too. What's the next multiplication expression I should write down for C?
20 times 26 equals 40 times
20 times 26
equals 40 times
will be equal to
40 times
40 times B, right? So how do I solve for B? First, I have to combine 20 times 26, and then I have to divide both sides by 40 to find the B, to find that value for B.
Wait, so that
What's 20 times 26?
520.
I'm hearing 520. So we have to kind of remove the 40 from the B, right? And we do it through division. What's 520 divided by 40? What did we get?
13.
13? Okay, 13. Good job on this. I'm going to tell you that I use proportions a lot in my normal life. When I'm working on recipes or planning for a party or whatever, the proportions really comes in handy. So you keep, these don't have any units on them. Like, remember our workbook page had players and teams and calories and ounces. That's sort of the next level, is adding in realistic terms and units. But this one is just getting you comfortable with solving for unknown parts in different places of proportions, okay? Any other questions? Are you feeling okay to finish this? Okay. Any other questions from my friends at home? I don't see most of your faces, so I can't see you shaking your head. I see Ryan's got a thumbs up here. Are we good? Nicholas, you good? Ryan, you good? All right. Thanks, guys. We'll do more of that workbook page as sort of like a warm up next time we get together. But proportions is definitely a real world skill. We're going to get good at it. I hear you're doing it in science too,
Yeah.
but more with the metric system, right?
Harder in science.
Yeah, it's a lot harder.
I think it's harder in science because it involves a lot of conversion between different units of measure and things.
There's days, there's years, there's
Yes.
converted.
Whew. All right. Have a great afternoon, everybody. Half day tomorrow, so we're not going to have a math class, both in person and online, but I'm going to release, hey, listen to this. I'm going to release the study guide for our coming test. You probably won't be able to tackle all of it yet because we have a couple sections left to practice next week, but at least maybe take a look at what you can manage over the weekend so that you're not studying for a big test in a couple days' time. I wanted to give you a little bit more time to prepare the content, okay? So look for that to come tomorrow. Do what you can over the weekend, and then we'll finish off chapter 10 next week, okay? Have a great weekend, everyone. Bye.